And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. We are looking at the sun as we do most days around this time, usually a little later than this time actually, coming at you a little early today. This is the 193 angstroms video from the SDO, and we see two sunspots in the south and a diffuse coronal hole system around the equator. Let's look at more data. Here's the 171 angstroms along with the colorized magnetogram. You can see those two sunspots down there at the bottom, and those are both beta class sunspots already. We've got two different polarities already going on both of those groups. So you'll see sunspotless days will end today, and the likelihood of things like solar flares, coronal mass ejections, etc. has gone up a little bit. Next, we're going to do some helioviewer movies of those active regions. Here's 304 angstroms. And I would note there is a plasma filament that heads off to the west out in this direction. Right there you can see this bubble in ionized helium, 304 angstroms. And a great view of those two active regions. Allow me to vanish. And here's the same area in 171 angstroms. My personal favorite wavelength. And thank goodness for the SDO. What an incredible observatory it is. So look for both of those groups to get named today. They've been there for quite a while. We actually covered one of those yesterday. 10.7 centimeter radial flux at 71, having come down off of 72. KP index is at 0, having been only at 0 or 1 for the past 24 hours. We don't see any significant solar flares. And there's the GOES X-ray flux. Again, the likelihood of seeing some solar flares is now much higher because we've got, I counted at least 4 ombre, 2 sunspot groups, both beta class. We don't see any big proton strikes or anything like that. Let's look at the magnetosphere right after we look at the real-time solar wind. And here's the earthly view of the heliospheric current sheet. Holy, what happened? Be careful with the real-time solar wind, folks. It'll get fickle. It'll get fickle on you. It has to refresh itself as it's an active applet. Anyway, current solar wind density around 5 protons per cubic centimeter. Solar wind speed down to solar minimum levels at 317 kilometers a second. Here is 4 hours of the magnetosphere. Nothing exciting going on there. And here are ground magnetic perturbations, and we don't see very many. Also 4 hours of data here. Welcome to the Polar Excursion. Welcome to the Neo-Renaissance. If you haven't checked out smAshomash.com, check it out. Check out our links. Check out our social media. smAshomash.org will redirect you. And we'll let this play through as it refreshed. Are you refreshed by YouTube videos? Or has the fear-mongering started to work on your patience? Here's the 3 days of the GOES magnetometer data, and we're seeing pretty smooth readings here. And we are solidly in the South Pole current sheet. Here's a view of the heliospheric current sheet magnetism. And you can see it's all South Pole oriented. We could snap into the North Pole oriented field at any moment, as we have sunspots south of the equator, and that's kind of the way that works without getting into a deep dive on that and getting into the weeds, since it's the daily space weather. Here's the line of sight field plot, a different view of essentially the same thing. This one shows you the B field in blue, and that's the sun's B field this time, unlike ground geospace magnetic perturbations, which is the Earth's B field. Nothing too crazy going on there. Not expecting those sunspots to be super huge, as we don't see any changes really in that field. Here's the coronal field plot, the field plot of the corona by itself, and it looks like we have some coronal hole interactions with the South Pole according to this data. And I don't have any comment, but it's time for another edition of the Smash Lights, where sometimes I rage and sometimes I don't. You'll just have to tune in. Now, today's daily space weather video, we're going to be talking about that hurricane, Hurricane Delta, winking as it had an eye and then it didn't have an eye. There's an earthquake swarm actually going on. We're going to talk cosmic rays also. So let's get into it. Are we going to talk COVID? Well, not really. By the way, we are streaming live to Twitch. If you haven't subscribed over there, check it out, twitch.tv/smAsho. Take a moment to press like and subscribe on YouTube if you enjoy the content. Check out our playlists. There are a bunch of them, and we've been making more and more varied content. We're also on BitChute and all over social media. Again, check out smashomash.org. And thanks again, Smash staff, for your efforts. There are all of our social media links right there, as well as our affiliate and so on. More on that later. And it's a cosmology segment. It's going to be shortened. Now, cosmic rays are important to Earth's climate. They have not been understood really in any real capacity until the mid-90s, when the Swedish Svensmark brothers wrote a groundbreaking and revolutionary paper about cosmic rays. Now, if you're wondering, I actually started reading about cosmic rays in the early 1980s. So let me just see if you can see this here. So this is the World Book Great World Atlas. And when I started learning about the Van Allen belts, I was about 4 years old. And here is this amazing magnetosphere image of Earth's environs. And if you look, there's actually a number B there. You see that straight line? That is actually cosmic rays. So it's showing you the Van Allen belts and so on. And yeah. So this is nothing new to me. I started considering the implications of cosmic rays in about 1980, maybe even earlier, as I learned to read at age 3 to avoid going to school, which didn't work out very well. But in any case, we monitor cosmic rays as one star or galaxy could suddenly turn on and make the planet cloudy for thousands of years, perhaps. Not the best prospect, and it's part of the reason why we study cosmic rays. Here are the cosmic ray monitors at Apatity and Barentsburg. And what we see here is big variation in the past week at Apatity as well as at Barentsburg. So we like to see the data corroborate here. Let's look at Athens, Greece, going a little farther south to a similar latitude to where I'm located. And it looks like we've got some erroneous data there. Do you think the cosmic ray flux really dropped that low? That would require like the entire sky to shut off. So some bad looking data there at Apatity. I mean at the Athens neutron monitor. Next, going even farther south, here's Mexico City. And we saw an uptick across all monitors here around the end of the month. And then you see these more varied readings Mexico City still pretty much flat on the past 30 days. And lastly, we'll look at Oulu, Finland, and DOMC, Antarctica. And there you can see Oulu, very similar profile to Apatity and Barentsburg. Here's DOMC, Antarctica. Once again, a similar pattern there, so that's a good thing, indication that the data is legit. DOMB, Antarctica, not sending data. If you want to monitor these yourself, just look up links to cosmic ray data. Network of cosmic ray stations, we use it regularly. And that's part of the reason why we've created the subject matter for our October contest. Now, it's more of a sweepstakes. We're giving away a free shirt for the month of October. By Halloween, probably slightly before that, we will announce a winner. We'll announce a deadline before that as well. All you got to do is head to smashomash.com/forum. We've got this forum pinned. So this forum is, this thread is stickied. Head to the free-for-all forum, and you see October contest announced. Just click on that. Set up a login if you haven't already done one. Type sign me up. Here's the design, by the way. And no, you can't buy this at the Teespring store yet. It is exclusive for the sweepstakes. Whoever wins will have the only shirt of this kind before even I have one. And it's designed to increase the knowledge of cosmic rays, their sources, and of, indeed, Deneb, aka Cygnus X3, if you're wondering about that. Yeah, it's a supermassive object orbiting another very massive object, a blue supergiant star. And this little friend, as it's called, has one of its poloidal field jets pointed directly at Earth. Note the way it looks like a swan. And Deneb is the tail of the swan, as well as the object at which things like Göbekli Tepe and other ancient megalithic sites are oriented. And here ends another edition of the Smash Lights. Thanks for tuning in, folks. Sometimes we do it separate, sometimes we do it together. And Be Stoic, thanks for leaving a comment. Just bought an RV camper. Well, congratulations, man. That's fantastic. I'm stoked for you. And I'm sure that will be a fun adventure. Let's talk electrons. Now, the Earth has electron belts. And the electron belts around the Earth, they hold in plasma. So there's a bunch of plasma in these areas. And they're held in by electrons. It is a bit of a mystery where the Earth's electron flux comes from. Is it only provided from solar electrons? Does it come out of the planet? Or is there a push-me-pull-you relationship between inductive incoming solar protons and the Earth's magnetic fields? Who knows? We really don't know where they come from or what's going on deep inside the Earth. It's part of the reason why we look at all the data to attempt to comprehend the relationships and the physics between this stuff. Let me just check the life of the stream here. And we are doing just fine. Here's a diagram of the layers of the atmosphere. All your weather occurs in the troposphere. Jets fly in the stratosphere. The mesosphere is the boundary between the ionosphere and the thermosphere. I mean, the mesosphere is the boundary between the stratosphere and ionosphere. And the bottom of the ionosphere is where you see things like the aurora borealis. And by the way, the GOES 16 endeavors to measure the electron flux right about at this level, at the ionosphere level, if you were wondering. So here's a 1-year graph of the electron flux, and we're back into a normal range here. We don't see charging hazards, and we're expecting a flat electron flux here over the next day or two. And there's the 3-day chart. Here's a 7-day chart again. We were in electron storm levels for about a week there, and everything's returned back to a fairly normal state. Here's a visualization of the total electron content. And we see some slight anomalies here, some oddities in the nighttime electron flux levels, but nothing to really write home about. Let's look at just one slice. Just the ionosphere layer. The previous was the entire air column from the thermosphere on down. And the ionosphere is looking, I don't know, pretty normal here. Not too crazy. As we've just entered southern hemisphere spring, are you enjoying the autumn so far? Are you forecasting deadly earthquakes on the solstice when the Jupiter-Saturn alignment happens? Next, looking at in-the-sky.org. I'm always interested in what's going on above my head. Where will you be when Deneb sets? Hey, check it out. Vega's just about to set, another member of the Summer Triangle. If you're up before dawn, you may see the moon and Mars sharing the area around the ecliptic. Here's what's going on in the solar system. There's where things will be in a week. And we've seen a big increase in 5+ magnitude earthquakes here, as well as another deep quake at Papua New Guinea, possibly another foreshock here. Let's keep an eye on that area. And when I say ion, oh, well, the pun is intentional. Please bear with me one moment. All right. Here at the Smash News Network, we try to maintain our integrity. Anyway, that 6.3 magnitude quake came in at 7:35 yesterday Universal Time, and it's at 103 kilometers depth. Here's another deep quake not too far away in the Solomon Islands. It's a 4.5 at 193 kilometers depth. So a bunch of 5 magnitude earthquakes kicking off, including the largest in Alaska for quite a while. That one is a 5.7 out in the Aleutian Islands. Here's a deep quake west of the Kamchatka Peninsula. It's a 5.0 magnitude at over 500 kilometers depth. The deepest quake I recall reporting on that area. Another deep quake at Papua New Guinea, right near the 6.3 magnitude. It's a 5.1 magnitude at 105 kilometers. A couple small deep quakes at Alaska. Here's a deep quake at Chile. It's a significant deep quake event, folks. It's a 4.3 magnitude. Here's a very deep quake at Fiji. 4.3 magnitude at over 600 kilometers. And lastly, one in Guatemala. A deep quake at 4.5 magnitude and 112.2 kilometers depth. Let's see what volcanoes are going off, and it's a bit of a lull in volcanic activity here. Although Ibu is exploding, it's producing a 7,000-foot ash plume. Dacono, excuse me. Dacono also exploding, flight level 070 there, 7,000-foot ash plume, and Sangay likewise exploding, 21,000-foot ash plume there. Please do not attempt to do the triple Lindy featured in the Rodney Danger film Back to School over the caldera. Here's a weather.gov map, and it's some bad times for places like Louisiana, as well as western Mississippi, and even some parts of Texas there. Here's the rain track according to Tropical Tidbits GFS forecast, and that is through Sunday at 0000 hours. And the majority of the rain will be done by the time you get up Sunday morning, at least the really bad stuff. There's the forecast, and that is not good news for Louisiana. Here is the water vapor maps for Europe and Africa, as we've got viewers from all around the world. You should tell your friends and foes, science noobs and science pros. Here are the water vapor maps for the Far East and Oceania. And please leave us a comment if you're from those locations. Here are the water vapor maps for the Americas. Yes, it's the NASA GOES Interactive Water Vapor Satellite. And you can see that hurricane making a sudden turn to the north there. By the way, here are the surface winds. And there's some bad news here in that we see a nearly counterclockwise rotation here ahead of the storm at 250 hectopascals. And that is not what you want to see, particularly, folks. An indication that it's going to remain pretty steady here and not weaken. Particularly, let's zoom out and look at the jet streams. There are the jets of the Western world. And it looks like we're going to see some stories about how Greenland's melting. We'll see how melted it is in a minute. Here are the jet streams of the Eastern world. Fairly coherent there. Although we do see the jet stream still blowing east to west over the entire Indian Ocean, which is not normal. Please leave a comment if you're a pilot. And let's see how melted Greenland is. Well, let's see. There's more than 5 meters of snow there. This is the snow depth chart on windy.com. How much snow is there? Oh my God, it's only 185.2 inches. 185.1 inches there. And here, only 4.2 inches of snow. But just south of that, more than 5 meters. Okay. Cool. Cool story, bro. Greenland is melting. Pardon the sarcasm. Next, looking at lightningmaps.org, it's where I go when I hear thunder. It helps me to convince my foes that I'm Thor, or perhaps Odin if I'm in an even worse mood. And we see lots of lightning strikes here over the Central Atlantic as well as the Caribbean. It's calmed down a bit in the Caribbean. The main strikes are happening there east of Bermuda, I'll say. And here's the NASA GOES lightning mapper. We finally see some significant lightning around the eye region, which only lasted for a little bit. So that's actually a good sign, folks. When you see a defined eye, that's typically a sign of a stronger hurricane. We see an eye for a moment and then it's gone as it's winked at us. And here's the US Doppler radar map. And you can see those heavy, heavy bands of rain already striking Texas, Louisiana, and Mississippi. Almost the entire state of Mississippi inundated. Let's do a close-up of the Gulf once again. And there's a pretty good view of that situation there. You've got a whole bunch of mixed up nonsense here behind the hurricane. You can see all these different altitude cloud systems all swirling around there. And let's go to the water vapor map as it'll be a little more insightful. And the nice thing about the water vapor map, folks, is that it will show you water vapor that is not condensed onto clouds. And if you're ever looking at a Doppler radar map, check out the water vapor map if you're not sure what's going to happen, as that water vapor can't hide from the NASA GOES interactive weather satellites. By the way, this is the GOES East. If you want to look it up yourself, look up NASA GOES interactive weather satellites. And you can see that eye wall promptly vanished. We've got a bunch of moisture here ahead of the storm. Not a good sign. And it's going to bounce off of this dry air and sort of head almost due north here. And I'm going to zoom in on myself for once. And if you're wondering where we're located, Smash staff and I are located right here in eastern Pennsylvania, practically within smelling distance of New Jersey. Fortunately, the wind usually blows from the northwest, and we can't smell the stench of New Jersey. No offense if you're a New Jerseyite. I'm referring to the government, because it stinks. In fact, it sucks. Thanks to our patrons, a true source of funding for the content. Please consider becoming a patron if you want the earliest updates and so on. Patreon.com/SmashoMash. As YouTube endeavors to pay us nothing for these videos, we make about 2 cents an hour to make these videos on YouTube. So thanks again to our patrons. If you want to appear on our credit crawl, become a patron. I suggest doing it at the $3 or higher level, as we'll be playing with our tiers at the end of the year. We've currently got 9. Because we are growing our organization, look for changes to the website to come soon. Check out our links. Again, social media is right there underneath that. And you've got Smash Forum, 2 Smash stores on Teespring and our affiliates. Check out our affiliate link. It's smashomash.com/affiliate. We've got a shopping list for you there. We've got amino acids. We've got methylsulfonomethane. We've got almond flour. We've got smashed potatoes, real respirators, the cartridges, the N95 caps that go over the cartridges, goggles, hazmat suits, chemical-resistant gloves, nitrile gloves, my bio bug out bag, and all kinds of other stuff. Make sure that your hair is smelling up to par, just in case Joe Biden may be standing behind you for a photo op. Make sure you've got a bottle of Garnier Fructis Sleek and Shine Conditioner. It's what I use to keep my hair as lustrous and fragrant as it is. You can find all that stuff and more at smashomash.com/affiliate. Thanks to the Smash team for tuning in. Allow me to vanish and invite you to smashomash.org. Again, visit our links. Please support us if you are able. Thanks for flying American Smashways, part of the Smash News Network. Today's featured SmAsho product is the Mensa shirt. Yes, Mensa. Yes, yes. Make Earth not suck again. It's up to you. And you can link to that at smashomash.org, smashomash.com. You'll see links to the Smash store and the SmAsho store. Check it out. Get some merch. Thanks for flying American Smashways. Please keep your head and arms inside the Smash plane at all times, as we've got a bonus features. We're going to show you the 335 angstroms view of the local yellow dwarf. We're going to show you the colorized magnetogram. And here that is. And there are those sunspots. They've actually grown a little bit since I did show prep. So there's a great view of both of those groups. And it looks like a possible third one forming behind there. Little uptick in solar activity. Don't be surprised to see the radio flux jump up also. As when I did show prep, I saw an umbra there, and there. I think we're going to be down to 3 based on the way the magnetogram looks. Here's the intensity gram. And are you ready to see umbrae? There you go. We've still got at least 4 different umbrae. And these are all different polarity here. This is South Pole, this is North Pole, South Pole, North Pole. Cycle 25 sunspots all day long. And those will most assuredly get named. They've already been there for quite a while. And last but not least, here is the 48-hour SDO video in 335 angstroms, which shows you the full life cycle of those sunspots. Thanks for tuning in. Remember, stare at the sun. Don't drink it. If you do, don't drive. Welcome to the Neo-Renaissance. Visit our sites, visit our links, support the channel if you are willing, ready, and able. We greatly appreciate your support. Please share the content on your social media. And again, tell your science noobs, science pros, your friends, and perhaps even your foes. And last but not least, may that solar wind be at your back and that covidiously absent from your locale.